2.1, frequency distributions and their graphs. Very well. So what is our goal? Our goal is to write down data in the format that actually makes sense. To analyze the data, you're looking for the shape or pattern in your data. You're looking for the center and also variability in your data. Okay, let us ask group 1 to start reading frequency distributions for the class.
Should I go? I guess. Okay. Definition. From the beginning or from the
From the beginning, you will learn.
Okay, you will learn that there are many ways to organize and describe a data set. Important characteristics to look for when organizing and describing a data set are its center, its variability or spread, and its shape. Measure of center and shapes of distributions are covered in a section 2.3. Measures of variability are covered in section 2.4. When a data set has many entries, it can be difficult to see patterns. In this section, you will learn how to organize a data set by grouping the data into intervals called classes and forming a frequency distribution. You will also learn how to use frequency distribution to construct graphs.
Thank you very much. Very well. So what are we going to do after we gathering the data, the collection of data? Suppose you have a lot of numbers here in your sample. Your goal is to get those data and write them in nicer or compact format. We call that format, for example, frequency distribution table. This is one of the easiest method to analyze the data. Okay, let us ask group 2 to read the definition for the class.
A frequency distribution is a table that shows classes or intervals of data, entries with the count of the numbers of entries in each class. The frequency F of a class with the number of data entries in the class.
Very good, thank you very much. So frequency is nothing but counting or repetition of your data. How many times, for example, number 5 is repeated in your collection? How many times number 7 is repeated in your collection? How many times number 49 is repeated in your collection, and so on. Group 2, please continue.
In the frequency distribution shown at the left, there are 6 classes. The frequencies for each of the 6 classes are 5, 8, 6, 8, 5, and 4. Each class has a lower class limit, which is the least number that can belong to the class, and an upper class limit, which is the greatest number that can belong to the class. In the frequency distribution shown, the lower class limits are 1, 6, 11, 16, 21, and 26. And the upper class limits are 5, 10, 15, 20, 25, and 30. The class width is the distance between the lower or the upper limits of the consecutive classes. For instance, the class width is the frequency distribution shown is 6 minus 1 equals 5. Notice that the classes do not overlap. The differences between the maximum and minimum data entries is called the range. In the frequency table shown, suppose the maximum data entry is 29 and the minimum data entry is 1. The range is then 29 minus 1 equals 28. You will learn more about the range of a data set in section 2.4.
Very good, thank you very much. Okay, so for example, in this table on the left-hand side, one example of a frequency distribution is given. So the smallest value in your collection is 1. The largest value in your collection is 30. So the minimum value is 1. The maximum value is 30. So in this table, they just gathered the data in classes 1, 2, 3, 4, 5, and 6 classes of data. Very well. Okay. Look at the first class. This is your first class. 1 is the lower limit in your class. Lower limit. And 5 is the upper limit of your class. Upper limit. The frequency or the count of the numbers in this class is 5. So let us move on to second class. The lower limit in your second class is 6. The upper limit in your second class is 10. In the second class, the frequency is 8. What's the meaning of that? It means that you have 8 values between 6 to 10 inclusive. The third class starts at 11 and stops at 15. The lower limit of the third class is 11. The upper limit of this class is 15. And the frequency or the count is 6. Next class, the lower limit is 16. The upper limit is 20. How many data are here? 8. It means that the number of counts or frequency of this class is 8. Next class starts at 21. So the lower limit of this class is 21 and the upper limit of this class is 25. The frequency is 5 or the count is 5. It means that you have 5 numbers in this class. And finally, the last class starts at 26 and stops at 30. The lower limit of this class is 26 and the upper limit of this class is 30. The frequency is 4. It means that there are 4 values in the last class. Very well. Okay, let me erase this upper limit, lower limit, and show you something. So take lower limits of the first 2 classes. 6 minus 1 is 5. Take lower limits of the second and third class. 11 minus 6 is again 5. Now consider these 2 classes. These lower limits are 16 and 11. The difference is again 5. 21 minus 16 is also 5. And finally, 26 minus 21 is 5. This number is called class width. So the class width is 5. And finally, the range of your data. To find the range of this collection, you take the minimum value in your table, 1. Then you take the maximum value in your table, which is 30. 30 minus 1 is 30 minus 1 is equal to 29. Any question here? This is the range of this collection, 30 minus 1 or 29.
I have a quick question.
Go ahead.
So the example of the frequency distribution, so to get that 5, you subtracted 6 minus 1, right? So you got the 6 from the second class?
Yes,
And then you subtracted it. Yeah, then you subtracted it from the lower limit 1, and then obviously you got 11, subtracted it from 6, and then you got 16, subtracted it from 11. So that's how you just keep finding them?
Yes, so if the table is given, you can subtract consecutives, lower limits or consecutive. Just to look at these. lower limits, 1 and 6, 5. 11, 6, the difference is 5. 16, 11, 5. 21, 16, 5. 26, 21, 5. Or you can look at upper limits, 10 minus 5, 5. 15 minus 10, 5. 20 minus 15, 5. 25 minus 20, 5. 30 minus 25 is 5. So again, if the table is given, you just do the subtraction.
Okay, the only other question I have is about the, so I get the class part, but what about the frequency? What is the 5, 8, 6, 8,
We're
5?
going to go over those. We're going to go over those.
Ah, perfect.
So
okay.
these frequencies just for a data that you don't have. It's just an example of a table. You don't have your sample, so you don't know what sample you have. This
Okay,
is just saying that, okay, we have a hypothetical sample and this is your table. Perfect. Thank you for the question. Group 3, please continue. Aki from group 3. Okay, we have a chat.
Oh, excuse me, just late in the sentence.
Guidelines.
All right. Guideline is contrasting frequency distribution from a dataset. Decide on the number of classes to include in this frequency distribution. The number of classes should be between 5 and 20, otherwise it may be difficult to detect any patterns. And to find the class wide as follows. Determine the range of the data, divide the range by the number of classes, and run up to the next convenient number. Number 3 is find a class limit. You can use the minimum data entry as the lower limit of the first class. To find the remaining lower limits, add the class wide to the lower limit of the
Preceding class.
Then find the upper limit of the first class. Remember that classes cannot overlap. Find the remaining upper class limit. Number 4, make a tally mark for each data entry in the row of the appropriate class. Number 5, count the tally masks to find the total frequency. What is this?
Frequency F.
Oh, yeah, frequency F, and for each class.
Thank you very much. Okay, guys, please write down the guidelines. First of all, you decide on the number of classes you want to have. So if the question doesn't give you the number of classes, it's totally up to you to select the number of classes. And it must be a number between 5 to 20. Then to find class width, you need to find the range of your data divided by the number of classes that you selected here. Okay. So for class width, let me write it for you here. Class width, it is range divided by number of classes. So first you have to decide on the number of classes. In step 1, you decide on the number of classes. In step 2, you find class width by dividing the range. Remember that range is maximum minus minimum. And you divide it by the number that is either given or you select. Then you start finding the class limits. What is the lower limit? What is the upper limit? And finally, you start counting the number of values in each class or in each bin, and then those are your tally marks. After that, you count those tally marks and you write a number under frequency F. Take a minute or two, finish writing the guidelines. So we move on to one example, see what's going on, to feel more comfortable about this topic. Ready for the example? Perfect. Example 1. So here you have a sample of numbers. This is the sample of numbers that you have. The question says, construct a frequency distribution that has 7 classes. So in this example, the number of classes is given. The number of classes is 7. So remember that in step 1, in the guideline, so take a look at the guideline here. In the first step, you have to decide on the number of classes. In the question, the number of classes is given to you. It is 7 classes. So it is 7. In step 2, you need to find the class width. Class width. Class width is equal to the range. What is range? The maximum value minus the minimum value. Divide by the number of classes, which in this case is 7. Okay, guys, take your time, find the class width for me, then we move on to next step. Very well. The class width. Your class width, you can round it up to get 40. The maximum value in this collection, so let us look for the maximum value in our collection. What is our maximum value? Is it 230? Is it, okay, 340. This is 40. Your maximum value. Maximum. What is your minimum value, guys?
65.
65.
65. Thank you very much. This is your minimum value. So the difference between 340 and 65 is 275 divided by the number of classes, which is 7, is 39.29. You can round it up to the next convenient number, which is 40.
40.
Any questions so far? Okay, so here we have 7 classes. Let us start by forming our table. Minimum value, 65. Maximum value, 340. Okay, excellent. How many classes do we have? 7 classes. What is class width? It is 40. So you start by writing the smallest value, 65, and you add 40 to 65. The next lower limit is going to be 105. Then you add 40 to 105, add 40, the class width, to 105 to get 145. You add 40 to 145 to get 185. You add 40 to 185 to get 225. You add 40 to 225 to get 265. You add 40 to 265 to get 305. So by adding class width, we form lower limits for each class. As you can see here, we have 1, 2, 3, 4, 5, 6, 7 classes. Okay, what about our upper limit? Our first class starts at 65 and it has to stop at 104. Why is that? Because next class starts at 105 and 2 classes has no overlap with each other. So after forming our lower limits, we can start writing the upper limit for each class. Lower limit of the second class is 105. So upper limit of the first class is 104. No intersection, no overlap. Lower limit of the third class is 145. So the upper limit of the second class must be 145, 1 unit smaller than. And you continue.
I had a quick question.
Go ahead.
So the upper limit is 104 because you said that the next class is 105, right?
Very good. There is no intersection between these two classes.
Okay, so just a quick question. Maybe you can give me an explanation. Why can't it be 106, for an example, past 105? Does that like intercept?
Yes, so 106 belongs to the second class.
Ah, okay, okay.
So your first class starts at 65 and it stops at 104.
So it has to end before the next class.
Exactly. Otherwise, you get intersection between them.
Perfect. Alrighty.
Okay, perfect. Next step, let us form a column for tally marks. So let's see. This is the table for tally marks. So here in the first class, here you have 1, 2, 3, 4, 5, and 6 tally marks. So the frequency is 6. What's the meaning of that? It means that we have to count all the numbers starting at 65 and stopping at 104. Okay, let us get to the collection here. How many data do we have? We have, okay, we have to count them. So it starts at 65. 65. Then next number between 65 and 104. Okay, we have 90. We have 100. So 3 so far. 85, then we have 80. Okay, let's see, let's look for everything, and 90. So how many do we have? 1, 2, 3, 4, 5, 6. So the tally marks for the first class is 6. 6 tally marks. 1, 2, 3, 4, 5, 6, and the frequency, or F, for simplicity you write F, is 6.
So Professor, how you get the frequency is just counting how many numbers that falls like in the between 65 and 104.
Yes,
right?
take a look at this, 65 to 104. How many numbers do I have? One of them is 100. Is 100 between 65 and 104? Yes. Next number is 90. Is 90 in between 65 and 104? Yes. What about 105? 105 is not in the first class. It's in the second class, so I'm not going to count it. Next number is 85. Yes, sure. Okay, let us move on to the second class. Second class starts at 105 and it stops at 144, and we have to count all of those numbers. If you count them, the tally marks says you have 9 tally marks. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 is the frequency of the second class. We can move on to next class and count all the numbers between 145 to 184 in your collection. Next class, all numbers between 225 to 264 inclusive. Next class, 265 to 304, we count all the numbers. And finally, 305 to 344, we count all the numbers, and it is 2. So here's a question. What if I add all of these frequencies? Question. What is the sum of all of these frequencies? What is the sum of all frequencies? If you add these together, 6 plus 9 plus 6 plus 4 plus 2 plus 1 plus 2 is equal to 30. This symbol here, this symbol is a Greek letter, uppercase Greek letter that we say it is sigma. The name of this letter is sigma, and it represents the sum. So the sum of all frequencies, it means that you add all of these together equals to 30. Okay, what's the meaning of 30 here? How many data do you have? Take a look at the number of data. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 3 times 10, 30. Here you have sample size equals to 30. And the sum of all frequencies must be equal to the sum, which is 30, equal to your sample size. Okay, please take your time. Write this down. So you officially form a frequency distribution table. Why we need this table? we take this table and we use it to graph a histogram to visualize the pattern in our data. Please let me know when you're ready. So we move on to next page. Very well. Okay, let's move on to the next page. So in example 1, you can include several additional features like midpoint, relative frequency, cumulative frequency to the data. Take a look at the definition. In this definition, you have the definition of the midpoint or middle value. The midpoint of a class is the sum, addition of lower and upper limits divided by 2. So you take the lower limit of the first class, you add it to the upper limit of the same class, and you divide it by 2, and you call it midpoint. Next definition is called relative frequency. Relative frequency of each class is the frequency of that class divided by sample size. It's either written in decimal form or percent. And finally, cumulative frequency of a class is the sum of the frequencies of that class and all previous classes. So the sum of frequency of the same class plus all previous classes. You take all of those frequencies, add them together, and you define something that you call cumulative frequency. Note that the cumulative frequency of the last class must be equal to the sample size.
Professor, what is the word that you write on the side of relative frequencies? Decimal?
Decimal or percent.
Okay, thank you.
Sure. Okay, we learned something new. Let's see how we can apply this definition to our previous example. Okay. Let us take a look at your example. In previous example, the answer is here. The first class starts at 65. The lower limit is 65. The upper limit is 104. You know that the frequency or the count of that class is 6. In the third column, we find the midpoint. To find the midpoint of this class, you add 65 and 104. You divide it by 2. Take a look at this. 65 plus 104 divided by 2 is 84.5. Guys, we do not round the midpoint. You leave it as it is. Then to find relative frequency, you take the frequency of the first class, 6, and you divide it by the total frequencies or sample size. You know that you have 30 numbers in your collection. 6 divided by 30 is 0.2. or 20%. Then cumulative frequency of the first class is nothing but the frequency of that class, because we don't have any other class before the first class. So you have to copy down the same frequency for the first class.
I have a question.
Go ahead.
Sorry, about this cumulative frequency. So it's okay. It's okay if you don't have it as a percentage. Is that right?
No, you just copy down the frequency that you have.
Okay. Okay. Thanks.
Very well. Let us look at our second class. Second class has a lower limit 105, upper limit 144. To find the midpoint, you add 105 and 144 divided by 2, and you get a decimal number 124.5. Again, you do not round the midpoint. You leave it as it is. Then to find the relative frequency, you take the frequency of the second class, which is 9, and you divide it by your sample size, 30. The outcome is 0.3 or 30%. Very well. Now for cumulative frequency. The frequency of the second class is 9. You have to add it to the frequency of the previous class. 6 plus 9 is going to be 15. So this is your cumulative frequency for the second class. You continue the process and you have a nice compact table, frequency distribution table. Please take your time if you want to complete your table.
Just scoot the screen a little bit up.
Sure. Better now?
No, just to see the other numbers that are up there, like how you did the math.
Oh, okay. Here you go.
Thank you, thank you.
And Professor, I have a question.
Go ahead.
So for on the bottom of page 42, is that also an method of getting midpoints?
Which part you're talking about?
On the bottom of, oh sorry. on the bottom of page 42.
Page 42. So I don't want to change that page. So let me open it for you on this screen. 42. Let's take a look at 42. The midpoint using the class width of 40. So by adding 40 to all of these midpoints, you can get the second midpoint, third midpoint, fourth midpoint. Yeah, of course. You're just doing algebra.
Thank you.
Yeah, you see the difference between these two. 124.5 minus 84.5 is going to be just 40. The difference between these two is 40. The difference between these two is 40, and so on.
But these are just different methods. They should all get the same solutions, right?
They must be the same.
Okay, thank you.
Sure. Okay, move on to next page. Okay, we have a chat. Yes, okay, thank you. Thank you for the confirmation. Very well. Now let us talk about the histogram. How do we use this table to visualize the data? Okay, first of all, to form your histogram, you need a horizontal axis. This horizontal axis represents your classes. So the horizontal axis represents the classes. And you need a vertical axis to either represent your frequencies or relative frequencies. So you can use a vertical axis to represent frequencies or relative frequencies. That depends on the question. Then you use bars, attaching bars to represent the graph or histogram. Okay, perfect. Let's get back to our example. Here you have, okay, this is the table that we had before. Classes 65 to 104, and the frequency is 6. You have the second class 105 to 144, the frequency is 9, and so on. You can form something that we call class boundaries. How do you form class boundaries? So here you have 65 as the minimum value in the first class, lower limit in your first class. You can just shift 65 a little bit to the left-hand side and get 64.5. So as a result, if you shift 104 a little bit to the right-hand side, you get 104.5. Now, the second class has boundaries, which is shifting 105 a little bit to the left-hand side, 104.5, shifting 144 to the right-hand side, 144.5. We only use these class boundaries to make these graphs attached together. That's the only reason we form class boundaries. So take a look at this histogram. 64.5 to 104.5. This first bar represents the first class. First class. The frequency of the first class is 6, so the first bar stops at 6. The second bar is representing the second class. The boundaries of the second class is 104.5 and it stops at 144.5. This is your second class. The frequency of the second class is 9. What's the meaning of that? It means that your second class stops at 9. It doesn't go up further. The same for the third class, fourth class, fifth class, sixth class, and the last class. So this is called the histogram of your data. Statisticians don't use this type of graphing. They use a software like SAS, like R, like Python to visualize this data. Okay, guys, please take your time if you want to finish writing these.
Professor, what is the graph on the left different from the one on the right?
So take a look at this. It says if you start, instead of starting at 64.5, you start at 84.5, which is, what is this number here? Is it familiar to you or not? 84.5, have you seen it before in the table somewhere?
Is it the midpoint?
Very good. Thank you very much. So instead of writing the lower limit, upper limit, you can use representative like midpoints and form your histogram.
Right, that makes much more sense.
Take a look at this. Class, midpoints.
I didn't pay attention to that.
That's
Thank you.
absolutely fine. Thank you for asking.
So just a quick question. So either graphs are a good representation or?
Both of them are absolutely fine.
Okay, perfect.
Can you scroll up really quickly?
Sure. Here you go.
Sorry, can you go to the properties? I just want to make sure I have them properly.
Properties up
Yeah.
here.
Thank you.
Sure.
And can you go to the definition of frequency histogram?
Frequency histogram. Here you are.
So the horizontal scale is used for like classes?
Classes. Very good.
Okay. Okay, I'm good. Thank you.
Perfect. Move on to next page, everyone. Perfect. So we have different types of graphs. One of them is called frequency polygon. Let us ask group 5 to read the frequency polygon for the class. Group 6, please read frequency polygon for the class.
A frequency polygon is a line graph that emphasizes the continuous change in frequencies.
Please read example 4.
Constructing a frequency polygon. Draw a frequency polygon for the frequency distribution in example 2. Describe any patterns. Should I go on?
Yes, please. Please continue.
Solution. To construct a frequency polygon, use the same horizontal and vertical scales that were used in the histogram, labeled with cross midpoints in example 3. Then plot points that represent the midpoint and frequency of each class and connect the points in order from left to right with line segments. Because the graph should begin and end on the horizontal axis, extend the left side to one class width before the first class midpoint and extend the right side to one class width after the last class midpoint.
Okay, perfect. So this is an example of frequency polygon. Move on to next page. Group 7, please read frequency histogram, relative frequency histogram.
A relative frequency histogram has the same shape and the same horizontal scale as the corresponding frequency histogram. The difference is that the vertical scale measures the relative frequencies, not frequencies. Example 5. Constructing a relative frequency histogram. Draw a relative frequency histogram for the frequency distribution in example 2.
Okay, thank you. So guys, your histogram must be the same as frequency histogram. Okay. On the vertical axis here, instead of using frequencies, we're using relative frequencies. Let's get back to our table. Let me show you. Okay. This is our polygon. Okay. Take a look at this. Let us get back to the table. Very well. Okay. So relative frequency of the first class is 20%. Then relative frequency of the second class is 30%. Relative frequency of the third class is 20%, and so on. So we are using relative frequencies instead of frequencies that we used before. If you use your frequency on the vertical axis, you just have your frequencies without percentage, without decimal. Very well. To form your frequency polygon, you used your midpoint. Now to form relative frequency histogram, you use these decimal numbers or percentage that you found for relative frequency. For example, for the first class, the relative frequency was 20%. So you stop at 0.20 or 20%. The second class has a relative frequency 30%, 0.30. So the second bar stops at 30%. And you continue. So that's the difference between relative frequency distribution and frequency distribution. Your vertical axis has different numbers. That's the only difference. The graphs must be the same.
Sorry, I have a question.
Go ahead.
It's always for the y-axis we put relative frequency. Is it?
If the question says relative frequency, yes, you have to use relative frequency. If the question says just frequency, you have to use frequency.
I see. Okay, got it. Thanks.
Okay, so let's move on to the next page. Let us ask group 7 to continue. Group 7, please continue.
Definition. A cumulative frequency graph or ogive is a line graph that displays the cumulative frequency of each class at its upper class boundary. The upper boundaries are marked on the horizontal axis, and then cumulative frequencies are marked on the vertical axis.
Thank you. Please read the guidelines.
Guidelines. Constructing an ogive cumulative frequency graph. 1. Construct a frequency distribution that includes cumulative frequencies as one of the columns. 2. Specify the horizontal and vertical scales. The horizontal scale consists of upper class boundaries, and the vertical scale measures cumulative frequencies. 3. Plot points that represent the upper class boundaries and their corresponding cumulative frequencies. 4. Connect the points in order from left to right with the line segments. 5. The graph should start at the lower boundary of the first class, cumulative frequency is 0, and should end at the upper boundary of the last class, cumulative frequency equal to sample size.
Okay, perfect. Please write down the guidelines. Again, this is not the methods that we're using in statistics. As a statistician, I expect you to feel comfortable now referring to softwares to do that. On the exam, for example, I don't expect you to graph things like this. I expect you to understand how the histogram is working. So I give you histograms and I ask you questions to analyze the histogram. Very well. Let us look at the last example.
Would it be a problem to just get the cumulative frequency definition?
Cumulative frequency definition. So you just take the frequency of each class and you add previous frequencies to that frequency. So it is the sum of the frequencies of that class and all previous classes.
Oh yeah, sorry, I meant the cumulative frequency graph. Sorry about that.
Oh, that's okay. Let's get back here. Here you are.
Thank you.
Very well. Let us take a look at our example here. In previous table, our cumulative frequency is this column. So relative frequency is not here. You're just working with your frequencies. The first frequency is 6. The second frequency is 9. If you add these two together, cumulative frequency for the second class is 15. If you add 15 and 6, you get 21, which is cumulative frequency of the third class. And you continue to form cumulative frequency for this table. Very well. Okay. The first boundary is 64.5. And as the guidelines instructed, you consider the frequency to be 0. Okay. 104.5 is the connecting number between two bars. Excellent. So as you can see, the cumulative frequency is 6. So you put a dot on 6. Then you have 144.5 as the connecting number between the second and third bar. And the next cumulative frequency is 15. So next point is on 15. You connect these points and you get your graph representing the cumulative frequency for this table. Please take your time, write this down.